Today we will be exploring molecular shapes and how they can be predicted using the VSEPR theory, or valence shell electron pair repulsion theory, using bond angles, electron pairs, and hybridization, in combination with polarity, and how electrons are distributed among a molecule. The first molecular shape is the trigonal bipyramidal. These molecules have bond angles of 90 degrees and 120 degrees. We will be using the example of arsenic pentafluoride to help give us a diagram of what a trigonal bipyramidal shape looks like. They have 5 shared electron pairs and 0 lone electron pairs, having an electron domain of 5, with a hybridization of sp3d. These molecules are nonpolar as they're equally distributed amongst 5 extra atoms. The seesaw shape has bond angles of less than 90 degrees and less than 120 degrees. We'll be using the example of selenium tetrafluoride to showcase 4 shared electron pairs and 1 lone electron pair. It also has a hybridization of sp3d, but this molecule has polar tendencies. T-shaped molecular shapes have bond angles of less than 90 degrees. We will be using the example of chlorine trifluoride. This molecule has 3 shared electron pairs and 2 lone pairs, giving it the same 5 electron domain, which equals a hybridization of sp3d. However, this molecule is polar. The linear shape seen here has an electron domain of 5, which means it differs from other linear shapes. This linear shape has 2 shared electron pairs and 3 lone pairs. The example we're using is triiodide. Triiodide has a negative charge, but it still has a hybridization of sp3d and is a nonpolar molecule. The octahedral molecular shape has an electron domain of 6, differing from the previous molecular shapes we've explored so far. The octahedral shape has bond angles of 90 degrees, and we will be using the example of perxenate. Perxenate has 6 shared electron pairs and 0 lone pairs, and due to its 6 electron domains, it has a hybridization of sp3d2, and this is a nonpolar molecule. The square-based pyramidal shape has bond angles of less than 90 degrees in different spots. We will be using the example of iodine pentafluoride to help describe what we are looking at. The molecule has 5 shared electron pairs and 1 lone pair, still giving it 6 electron domains, and the hybridization of sp3d2. The square-based pyramidal molecule is a polar molecule. And the last molecular shape we will be exploring is the square planar. This has bond angles of 90 degrees. We will be using the example of tetrachloroselenium with a charge of 2. Selenium has the charge of 2, and the molecule has an overall charge of -2. There are 4 shared electron pairs and 2 lone pairs, giving it a hybridization of sp3d2 and a nonpolar molecular format. That is all of the molecular shapes we'll be exploring for today.